And RS codes that can be decoded by the same iterative procedure like Berlekamp iterative procedure, Berlekamp's iterative procedure. But the main steps involved in this algorithm are the syndrome calculations. It is a little bit different compared to the earlier case. Now, from the received code word, whatever may the received code word, it is represented as R of X. Now, the syndromes that can be calculated by simply S1, syndrome S1 based on the number of error corrections. In our example, we have taken S1, say T is equal to 3. Now, S1 is equal to simply R of alpha. S2, R of alpha square. S3, R of alpha cube. S4, R of alpha power 4. S5, R of alpha power 5. S6, R of alpha power 6. So here, like this we can substitute. And let us assume, okay, and the received code word R is equal to R of X is equal to, okay, and it is alpha power 7 X cube plus alpha cube X power 6 plus alpha power 4 X power 12. This is an example which they are given. So that means there is an error in the 3rd, 6th and 12 position. So we know this error in 3, 6, 12 error. So that is a assumption. Now S1 that can be calculated by okay, and with the substitution X by alpha. Now S1 is alpha power 7 alpha cube plus alpha cube into alpha power 6 plus alpha power 4 into alpha power 12. It is nothing but alpha power 10 plus alpha power 9 plus alpha power 16. Alpha power 16 is nothing but alpha. So here we'll get it is simplified as alpha power 12. Like that, S2 is equal to R of alpha square, it is equal to 1. S3 is equal to R of alpha cube, it is equivalent to alpha power 14. S4, it is nothing but R of alpha power 4, it is alpha power 10. S5, it is R of alpha power 5, it is equal to 0. S6, that is nothing but R of alpha 6, that is equal to alpha power 10. You see, similar to the BCH decoding, once syndrome components are calculated, Berlekamp iterative algorithm, okay, it will calculate the parameters based on the d mu value. Okay, and if d mu is equal to 0, it follows the same thing. Sigma mu plus 1 x is equal to sigma mu x. L mu plus 1 is equal to L mu. D mu, if d mu is not equal to 0, then sigma mu plus 1 x is equal to, here minus sign is used, but here the pattern is same. L mu plus 1 also is there. But here one important parameter for this consideration is, rho is considered prior to muth rho, and d rho is not equal to 0, and another constraint for this case is, and rho minus L rho has the largest value. That is a one modification you can consider here. The remaining all are more or less same. If d mu is not equal to 0, sigma mu plus 1 x is equal to sigma mu x plus or minus d mu d rho inverse x power mu minus rho sigma rho x L mu plus 1 maximum of L mu comma L rho plus mu minus rho. Rho is considered as prior to the muth rho. If d mu is is equal to 0, previous values you have to retain, and the updated value d mu plus 1, it follows the same pattern. Similar to the Berlekamp iterative procedure for BCH coding, even for RS coding also, we'll start with the table iterative procedure with default values. Mu is equal to -1, 0 rows are default values. Mu is equal to -1 row that can be represented with -1, 1, 1, 0, -1. And mu is equal to 0 row correspond to mu is equal to 0, 1, a polynomial is 1, d mu is equal to s1, l mu is equal to 0, mu minus l mu is equal to 0. Now we'll discuss about if you want to update for mu or mu is equal to 1 row. So now I will take mu is equal to 0 and d naught value, d naught is equal to s1 in our example, that is equal to alpha power 12, that is not equal to 0. So now with this assumption we have to find all the elements corresponding to the next row. Mu is equal to 1 because d naught is equal to alpha power 12, which is not equal to 0. First we have to find row value, and correspondingly we have to find L1 sigma power 1x, and later on we have to find D1. Now the elements are calculated by, for mu is equal to 0, d naught is equal to s1 alpha power 12, that is not equal to 0. Now you have to take row value which is paired to mu. So here mu is equal to 0 and pair value is a -1 and row value is taken -1 directly. L mu plus 1 according to the formula maximum of L mu comma L row plus mu minus row, and accordingly we will get L1 value as 1, and sigma mu plus 1 x. So sigma mu x minus d mu d row inverse x power mu minus row sigma power row x. Okay, and accordingly with the numerical values, mu value is 0, that's why mu plus 1 is equal to 1. Sigma 1x is equal to sigma power 0 x plus d naught d minus 1 inverse x power mu value is mu value is 0 and row value is -1, 0 minus of -1, that is x power 1 sigma power -1 x, and we'll get the value 1 plus alpha power 12 x. And based on this d1 value that can be calculated s2 plus sigma 1 power 1 s1, and finally we'll get alpha power 7. Now the updated values in the table corresponding to 1, okay, and sigma mu x is sigma 1x is 1 plus alpha power 12x. Now d mu which we have calculated, it is alpha power 7, and L mu L1 we got 1, and mu minus L mu it is equal to 0, and in this we assume rho is equal to -1. That is our assumption. This is updation for mu is equal to 1. Mu is equal to 1, d1 is equal to alpha power 7, which is not equal to 0. Then we have to take the prior value, rho is equal to 0. L2 value with this calculation, L2 is equal to maximum of L1 comma L0 plus 1 minus 0, and we'll get the value of 1. Sigma 2 of x, it is nothing but sigma 1 of x plus, okay, and in this polynomial sigma 2 of x that can be obtained by sigma 1 x plus d1 d naught inverse x power mu minus rho. Mu value is 1 in this case and rho value is 0, sigma power 0 x, and by substituting the values from the table, so here the values are like this. Sigma 1 x is 1 plus alpha power 12 x by substituting the same thing, and d1 is alpha power 7, and d naught is alpha power 12. D naught inverse is alpha power 12, and its inverse is alpha cube, because the highest power is 15, so that's why here you have to subtract from the 15. X power mu minus rho, it is 1 minus 0 1 x into 1, finally 1 plus alpha power 12 plus alpha power 7 into alpha cube into x. Alpha power 7 into alpha cube is alpha power 10. So straight away we'll get the simplification. Sigma 2x is equal to 1 plus alpha cube x. And based on this we can calculate d2 distance. d2 is equal to s3, say syndrome vector s3 plus sigma 1 superscript 2 s2 plus sigma 2 to s1. By assuming the syndrome values s3 as alpha power 14, sigma 1 2 means it is a coefficient of coefficient of x, because there's a 1, coefficient of 1 x for this polynomial, for this polynomial. So according to the previous notation, the coefficient of x is alpha cube. The same thing I substituted, and s2, syndrome vector s2 is 1. By simplifying this, we'll get the d2 value 1. Now by updating the same in this representation, now in the table, for mu is equal to 1, this is, we have taken these values to update a 2, the second row, mu is equal to 2 row, mu is equal to, and sigma 2x is just we have completed, it is 1 plus alpha cube x, and d2 is 1, L2 is 1, already noted, mu minus L, mu is 2 minus 1, 1. It is a way to complete second row with the knowledge of mu is equal to 1. Okay, and here to update the table mu is equal to 3, we have to take the previous row, that is mu is equal to 2, d2 is equal to 1 according to the previous calculation, and it is not equal to 0. Now the difficulty is the consideration of the row is equal to 0. Row is equal to 0, and which value you have to take, that's our representation. Okay, because d mu is not equal to 0, we have to take sigma mu plus 1 x, L mu plus 1, and the row, and the consideration is row is considered prior to the muth row, and d row not equal to 0, and special condition of RS decoding, row minus L row has the largest value. In this case, actually we have to assume the row value. Prior to the mu value means we'll assume row is equal to 1. But according to the table, for row is equal to 1 or mu is equal to 1, d row is not equal to 0. That condition is satisfied. But another condition, row minus L row, that is 1 minus 1, 0. It is not the greatest value. That's why we'll go for the even prior value, like row is equal to 0. In that case also, we have the condition d row is not equal to 0, s1 value, that value is alpha power 12, and here also we'll get the row minus L row, 0 minus 0, we'll get the 0 value. Which value you have to choose? Here based on the d row value. Okay, and d naught value is alpha power 12, and d1 value is alpha power 7. Out of these two, alpha power 12 is a high value. That's why we'll assume row is equal to 0. Okay, and according to this condition, we have to assume row is equal to 0. That's the reason to assume row is equal to 0. And with that, we can take row is equal to 0, and after that, the remaining calculations are based on this representation. L3, okay, and length that can be calculated by maximum of L2 comma L0 plus mu minus rho, 2 minus rho. So assumption of this value, that is an important concern. And for the next steps, there is no ambiguity, because remaining all are having the greatest values. Only for this step we have the ambiguity, because rho minus L rho, in both cases we are having the 0 value. That's why based on the d row value, we'll assume rho is equal to 0, and accordingly we'll get L3 is equal to 2. Then sigma 3x, which is nothing but sigma 2x plus d2, mu value is a 2 in this case, d2, d naught inverse x power mu minus rho, mu value is 2 and rho value is 0 in this case, sigma power 0x, and then we'll get 1 plus alpha cube x, that is a sigma 2x directly. d2 value is 1, d naught is d naught value is because we have to assume rho value is 0 and d naught value is alpha power 12, so its inverse is alpha cube, x square into 1. Finally it is simplified as sigma power 3x is equal to 1 plus alpha cube x plus alpha cube x square. And from this d3 that can be calculated by directly, so it is actually s4 plus sigma 1 power 3 into s3 plus sigma 2 power 3 s2. With this substitution, we'll get the representation like this. d3 value is alpha power 7. Okay, and by substituting these values, okay, and here we can update third row according to our representation. Third row, those values are represented as third row, and the polynomial as we calculated sigma 3x. The polynomial is 1 plus alpha cube x plus alpha cube x square, and d mu, just now we have calculated d mu is alpha power 7, and L mu, its value is 2, mu minus L mu, its value is 1. In this we assumed rho is equal to 0 only. This is a table so far we have considered. So to update fourth row, mu is equal to fourth row, and assume mu is equal to 3, d3 is equal to alpha power 7, and its value is not equal to 0. Okay, now we have to take the prior to mu, that is rho is equal to 2 in this case. Here there is no ambiguity because rho minus L rho, its value is d mu value is 3 and the corresponding representation. Okay, and we are assuming rho is equal to 2. There we are getting 2 minus L rho, its value is 1. 2 minus 1, we are getting 1. Because rho is equal to 2, we can find rho minus L rho. Rho is a 2 minus L rho. L 2 is 1. So in this case, we can assume the values like this. So here, with the assumption prior to 3, its value is 2, rho is equal to 2, and L2 is 1. 2 minus 1, 1, which is having the greatest value. So here, there is no ambiguity as far as the rho is concerned. And after that, L4 is equal to maximum of L3, L2 plus 3 minus 2. With that, L4 value is 2, and sigma 4x, the formula is sigma 3x plus d3, d2 inverse x power 3 minus 2, sigma power 2x. Sigma 3x, we know, just now we have calculated 1 plus alpha cube x plus alpha cube x square. D3 value is alpha power 7. D2 value is, actually it is 1, its inverse is also 1. X power 3 minus 2, it becomes x. Sigma 2x is 1 plus alpha cube x. With the simplification, we'll get sigma 4x is 1 plus alpha power 4x plus alpha power 12 x square. After that, d4, that can be calculated by S5 plus sigma 1 4. Sigma 1 4 means the coefficient of x for the polynomial sigma 4x. Sigma 1 4 S4 plus sigma 2 4 S3 plus sigma 3 power 4 S2, sigma 4 power 4 S1. And according to our calculation, S5, syndrome vector S5 is 0. Okay, and alpha power 4 into alpha power 10 plus alpha power 12 into alpha power 14. So with these calculations, so normally we'll get D4 value as alpha power 10. Values which are calculated, okay, just for reference I'm giving. S1 is equal to alpha power 12, S2 is equal to 1, S3 is equal to alpha power 14, S4 is equal to alpha power 10, S5 is equal to 0, and S6 is equal to alpha power 10. We are substituting the same value. S5 is equal to 0, S4 is equal to alpha power 10. So based on that, we'll get D4 is equal to alpha power 10. Now the fourth row or updated row is represented like this. Mu is equal to 4, and the corresponding polynomial is 1 plus alpha power 4 x plus alpha power 12 x square. D mu is equal to alpha power 10, L mu is equal to 2, and mu minus L mu is equal to 2, and the corresponding row value is 2. And to update the fifth row, okay, and assume mu is equal to 4. D4 in this case is alpha power 10, which is not equal to 0, and we have to take row value prior to the muth row, and that is 3, because D3 is also not equal to 0. So accordingly, L5 is equal to maximum of L4 comma L3 plus 4 minus 3, and we'll get L5 is equal to 3. And sigma 5 of x, that is nothing but sigma 4 of x plus D4 D3 inverse x power 4 minus 3, mu minus rho, actually it is sigma 3x. With the substitution, this is a simplification, and finally the polynomial sigma 5x 1 plus alpha power 7x plus alpha power 4 x square plus alpha power 6 x cube. and the corresponding distance d5 that can be obtained by s6 plus sigma 1 5. As I mentioned, sigma 1 5 is the coefficient of x for the fifth polynomial. Sigma 1 5 s5, sigma 2 1 s4, sigma 3 1 s3, sigma 4 5 s2 plus sigma 5 5 s1. With the substitution, we'll get d5 is equal to 0. So the updated table is like this. Mu value is 5. Sigma mu x is 1 plus alpha power 7x plus alpha power 4x squared plus alpha power 6x cube. And d mu is equal to 0. L mu is equal to 3. Mu minus 6, L mu is equal to 2. And the sixth row that can be calculated by, now mu is equal to 5 and d5 is equal to 0. Then sigma mu x or sigma 6x is nothing but sigma 5x straight away. And to update the sixth row, you have to assume the values like this. Now the updated table is like this. Now finally the solution that can be identified by substituting all the primitive roots like 1 alpha alpha square up to alpha power 14 into the sigma x. Okay, and when we'll get the zeros, that is treated as a root, and roots are alpha cube, alpha power 9, alpha power 12. And reciprocal of these roots are, that means by subtracting from 50 and the powers, we'll get alpha power 12, alpha power 6, alpha cube. That means error in the third, sixth and 12th positions. So this is a decoding procedure for RS, Reed-Solomon codes.